Welcome, welcome, welcome. I'm your host, Alex Gizis, and this is Mike.
Hey guys.
We are developers of Speedify, and this is Office Hours. This is your chance to ask us questions. So if you have questions, type them in the comments on either YouTube or Twitch, wherever you're watching, and we will answer. All right. All right. Andrew says, why do I get slower speeds with Speedify than with Starlink alone? I connect from Ashburn, VA near your data center. With Starlink alone, I get 250 megabits. With Speedify on my router, I only get 100 megabits. Latency is similar on both.
That's a tough one.
Send logs.
Yes, please. And try a different server, see if that helps.
Our audio is cutting in now. Anyone else hearing that? Mic.
Hello?
We have good internet. All right, Andrew. Brian's going to ask you some questions here. Let's, let me see. Oh. All right, so let's look at Speedify that we're using right now. So Andrew says we have bad audio. Streaming redundantly. Look at that.
Little hitch, yeah.
Our Wi-Fi glitched out pretty badly with loss in it. I don't know if that's related or not. Could be. So I've got both Wi-Fi and Ethernet going to our Comcast internet. So that's not giving me much fault tolerance. But I have a tethered iPhone, so that's what gives us the AT&T. While we're at it, there's pair and share. This is a feature where you can reach out on the Wi-Fi and borrow another Speedify device's cellular. Hey, look at that. It's Mike's iPhone. All right, Mike, you want to hold up your iPhone?
Yeah, sure.
There we go. So let's try this. So I am going to tap to pair. Attempt to pair, yes. Send a request.
Boop. I'll
Mike
accept.
has it. All right.
We'll pop up. Okay.
Receiving from Mike's iPhone. So we go back to the dashboard, and now I have 4 internet connections. And yeah, we're immediately giving you redundant copies of the data. Speedify is not happy with the Comcast internet today. But it's doing what it takes to keep us online.
Yep.
All right. So that's our little demo. All right. So, while Brian and Andrew discuss his Speedify router issues in the comments, go ahead, keep going. The topic today is this T app. People are reporting that it was made with AI5 coding, but that it had security flaws developers didn't know about, and now its Firebase database has spilled all the tea. Their database, which had the driver's licenses of all of their users, has been dumped online. Privacy disaster. So, is this Vibe Coding's fault?
It's human error as always. Vibe coding can only take you so far, but as a developer, you have to be able to monitor this stuff. And the big part was their privacy policy said, hey, after we verify you, we're going to delete your information, and they just kept it.
Yeah, that can't just be like, I mean, you'd have to be pretty incompetent for Vibe Coding to delete. Like, you said you're deleting them all. Yeah. And in fact, you have this growing database of thousands and then millions of people's.
Yep. Driver's license,
how could you have missed
selfies.
that? So I mostly think these people were just lying.
Yeah, I think it was malicious. They're probably using it to sell that data elsewhere and promising the people something different. But I don't know how, me as a developer, I couldn't sit on a couple million driver's licenses and be okay with that. I don't,
Yeah. When GDPR showed up, there was a moment of like, oh, what the hell? The Europeans are telling me what to do. I don't have to. And that's,
they were right.
They're right?
Yeah.
Like, I should not be holding on to someone's private information that I
No.
do not need to give them the service that they're asking for. Like,
Yeah.
why would I hold on to a copy of your driver's license?
There's no
I don't
need.
want it.
No.
I don't want it. It's just bad news, right? Interesting. Andrew's on a Flint 3 GLI net. All right, let's keep going. Yeah, I'm not sure if we have a Flint. Well, there are Flints in this office, whether they're 2s or 3s. I'm not sure. So I think the T thing, blaming the AI, is wrong. People, answer Andrew. Is audio cutting in and out? I can try all sorts of things, but all right. Send logs to support. All right. Nope. It takes so long to respond that I end up like triple clicking. It's support at speedify.com and send logs. But vibe coding, I was in the gym. I saw a friend of mine was talking about how his developers are getting 10 times as much done, maybe more. Things that used to take months, it's getting done in a day. I don't believe him.
Well, that's a little extreme.
Am I missing something?
I mean, it's a little extreme.
I'm paying for Claude, and
I think you take, they have that.
I feel like I'm drinking more coffee watching this thing talk to itself about what it's going to do to my code. And I'm not saying it's useless. It's not useless. It's definitely.
It can be a lot more work than you think. But I think there's a place for it. I think it's great for pair programming. And just, we had a recent hackathon, and one of our developers built, Brian and Kevin was telling me a story how they built this beautiful dashboard with this data. It took 10 minutes. It was gorgeous. And then switching little tweaks about it took another 2 hours. So that's exactly what vibe coding is. And that's what kind of, predicament you can get into. And this is just a hackathon project. So when you go deep into development, you got to know what you're doing.
Yeah. Interesting. Let's see what else. So, are any of you guys vibe coding these days? Anybody in the audience trying to let Claude or ChatGPT or whatever just build whole apps for you? We'd like to hear about it. Also, obviously, any issues with Speedify, we'd also like to hear about them. In the unlikely event that it's not working perfectly for you.
It should always be working perfect.
And there we go. So what else? Actually, should we take a step back? What do they mean by vibe coding?
Yeah, it's a term. It's a new term. So basically, vibe coding is when you just you describe what you want to build to AI, and AI basically just builds it for you through iteration, and it'll ask you like, do you want this? And you could say yes or no, and basically it takes all the intensive thinking out of it and does it for you.
All right. Sean says, I connect my router that uses Speedify to my laptop via Ethernet. How can I use the pair and share from my phone to the router? My company turns off the Wi-Fi when Ethernet cable is plugged into the laptop. Okay. So, on the router, usually, it depends what kind of router you have. Usually, there's some kind of web front end. And in a lot of cases, if it's OpenWRT, Speedify can actually install itself into there, and you can go in and use that same user interface, including pair and share. If not, the command line interface, if you can get in, get a terminal on your router, there's the same command line interface. And the commands for pair and share are net share in the CLI. Isn't that what we call it?
Yeah, I was going to bring that up.
Perhaps we can find a terminal window here to demonstrate. And perhaps we can't. All right. Boom, boom, boom. Yes. Okay. So, boop. We go here. Let's see. Does Command Plus give us bigger fonts?
Nice.
So you guys can see it while streaming? Yes. Drag it over a little bit. All right. Look at this. Making up as we go along. So there's this command Speedify CLI. It is the same now on Mac. If you get it from us on Windows, on Linux, including the router versions, and if you just run the command, GLInet barely X. So yes, it should, right? Speedify should be installed. If you go, so that they have the GLInet user interface. We don't plug into that, but it's got a link there to see the old style user interface. And if you click that, Speedify should be added, and you should be able to get the whole thing. But here, there you go. Network sharing. These are all of the commands to do pair and share. It's a little awkward. If you can get the user interface, that's much easier. It shows you the discovered devices. You click on them, it connects. But everything it does, you can do by running Speedify CLI, net sharing, discovery, connect, blah, blah, blah. And there's some documentation online about that. But hopefully you can get the user interface up on your GLInet. Yeah, there's a lot of people, by the way, running Speedify and GLInet.
It's a very popular.
All of a sudden, it's nice. And I will say, just this week, GLInet has been stepping up and giving us support.
That's fantastic.
Trying to get proper support so we can do clever things.
So would that allow branding on their website with Speedify, or?
Yeah, probably. But
Great.
for now, it's our technical questions are actually answering.
Oh,
and
there you go.
So yeah, there'll be a few GLInet specific improvements probably in the next release.
Oh, fantastic.
The ability for us to see what's printed on the sticker on the bottom of the router.
It's the small things, yeah. But that is very big. That's huge.
How long before programmable delays are added in the GUI? Next release. It was supposed to be last release. We didn't think it was quite good enough to.
We held it off.
We got it done, but then decided this wasn't quite good enough. So Mike and Kevin, who's often on this, have been reworking that. It's going to be a jitter buffer feature where you can say, right, if you hate, perhaps because you're doing voice apps, if jitter is really bad for you, you can set a latency which is higher than the latency of any of your connections, and we will lock that in for you. Right? Obviously, in the ideal world, you have low latency and low jitter.
Right.
But sometimes physics gets in the way. So if you hate jitter more than you hate latency, you can agree to a higher latency and we'll make the jitter go away. It's the jitter buffer feature. You can apply it just on certain ports, just on certain IP addresses, just on certain protocols, and
even domains. Yeah,
it'll be next release. Is that 2 weeks from now? Could be 3 weeks from now.
Yeah,
I don't want it to be too long, but they tore it up. We thought we got it done, and
it's even better. So it's good.
Okay, so going back. Questions are coming by fast and we can answer them now. So I'd like to see. Besh asked, can you use software to drop internet ping or latency to play around 20 to 30 milliseconds at a global scale such that someone down South Africa can do online gaming with someone in the US at 20 to 30 milliseconds? Sorry, Besh, you are starting to run into speed of light problems. A lot of latency is caused by, too bad memory buffers, bad software, low bandwidth connections, but in the end, you cannot go faster than the speed of light. And in fact, if you're going fiber optic cables, you can't go faster than 70% of the speed of light. Turns out the speed of light through glass is significantly slower than the speed of light through space.
Who would have thought?
Yes. So it in space it's 2 billion meters per second, which sounds like a lot until you think about how far apart things are in space, and then you realize, oh my God, it's so slow. But when going through a fiber optic cable, it's only 1.4 billion meters per second, which people have pointed out, and this is kind of interesting. In a lot of cases, if you're going that far, that the curvature of the Earth is a thing, it can be faster to laser up to a satellite
Beam down.
that lasers straight across and then lasers back down. Because the laser
going through space.
is going through space, it goes full speed. So even though there's extra steps,
Yeah.
if you're going far enough, going straight line in a laser through space can be much, much faster. And I was really surprised that was true, but I did the math, and they're right.
So what percentage of the speed of light would it be doing the beams?
So it would go basically full speed. I mean, the speed of light through air is a tiny bit slower than through vacuum, but it's not measurable, not like the glass thing, right? I mean, obviously, physicists can measure it when they set up a thing, but you're not going to just notice it really. And there's a little bit of time that the satellite, kind of has to read it in and then send it to the other, right? So that's an extra delay of, a millisecond kind of thing on each end. You got to read the packet into a memory buffer and then write it out. But it's not much.
So you're going almost another 30% from FiOS. That's huge.
Yeah. I mean, there's a little extra. You have to go, 70 miles up.
Even 20%
and
would be
70
fantastic.
miles down. But 140 miles, how long does it take light to go? Not very long.
It's the future. It's coming.
Is it possible to speed up downloading games on Steam? Depends what your bottleneck is. If you are on gigabit fiber and your download on Steam is not getting even close to a gigabit, that means Steam is the bottleneck and there isn't much we can do.
Yeah.
If you're on a cellular connection and your download is not nearly as fast as you got that time you were at your friend's house who had a fiber optic connection, then now Speedify can help. Okay, Now we can put together a couple different phones. Put together, is there a Starlink? Is there, what you can put together a bunch of connections to get your speeds higher, to get up closer to that top speed that Steam will support. So the answer is, it depends. But yeah, no, if you are somewhere where your internet is not fast enough to download things from Steam at the rates you're used to, then absolutely Speedify, you can put together a bunch of connections and get those speeds way up. All right. There is the documentation on the CLI. Sorry, they asked with more data. I've wired connections and mobile tethering, and I want to bond them together. In Speedify UI, it looks like it's working, but Steam is only using primary. You can go in the UI. Let's go in the UI, and you can choose that cellular connection. And on priority, you can change it to primary. I'm not going to mess that now. I'm happy with my settings. And this is the real Speedify that we're streaming through. But you can change it to primary right there, and that'll tell Speedify, just go ahead and use it. I'm good with you using as much as you want. So that should help. All right, I'm a MikroTik and Cisco fan, but now that I've learned some OpenWRT, GLI.net's pretty good, but using Lucy is buggy on it. Interested on what bugs you are seeing. Yeah, so we're playing with it. Let's just say we've written some code to fix a few little bugs in Lucy that bothered us, but we don't know if those are the bugs bothering you. And I would actually really like to hear, Andrew, if you could tell us more about what things in Lucy are bothering you. So Lucy is the user interface for OpenWRT, for anyone who's not familiar. All right, so which Wi-Fi should the phone connect to for parent share to the router? The same for receiving Wi-Fi to the router, or the Wi-Fi the router is broadcasting? I think that either work, right? But usually you want to have your phone join the Wi-Fi that the router is making, so that it both can pair and share with the router, and also it can use the router's bonded connection. So that's probably the best. All right, Dean. Your video on AT&T long lines was so cool. Nice. Yeah, we've got a couple new videos out there worth seeing. There's one that people here are pretty excited about. I have a tendency to grab tiny pieces of graph paper and draw little diagrams for people explaining concepts. And I did that in front of the marketing people, and they found it so funny that they picked up a camera and said, say that again. Oh. Explain to us how Starlink phased array antennas work again. So I took a little piece of paper, I wrote it up, and I explained to them how Starlink phased array antennas work. So that video is up there, and it is getting hits. Nice. People seem to like it. So we've got, a bunch of things. We've got a YouTube about how the new Starlink dish update lets the dish track multiple satellites at the same time. We've got another one, which is the first one, about how the Starlink uses 1,000 antennas at the same time to talk to the satellites. That's the phased array. And another one with Brian Pradell and I talking about Google Tara, their crazy laser system for delivering internet instead of fiber optics. And that's actually one of the weird points that, people are saying, well, one of the downsides of it is that, of course, weather. Yes. If you put up two lasers on roofs to talk directly, the weather can interfere, and that is true. Although they say they have a lot of smarts to deal with bad weather. But also true is that a laser through the air is much faster than a laser through fiber optics. So if you are someone who is counting, your fractions of a millisecond, that could be significantly faster. All right, Vadim asked, do you know about quantum networks' advantages? How future upgrades will impact the current infrastructure and users? Actually, I do. I do know quite a bit about them. So here's the cool thing that the quantum networking technologies deliver. You can send a message and only one person, this is the weird quantum, you use a laser and you send your message in like one photon, one encrypted photon to the other person. Only one person can ever receive that message. If someone listens in on it, then it doesn't make it to the person you were sending it to. That's great. And if it makes it to the person you were sending it to, they know for a fact that no one listened in. And there's no way for the person listening in to make a matching photon, to be a man in the middle. It's impossible. So that is the cool thing, this sort of perfect security at one layer. At one layer, perfect security. You send a message to the guy, if he gets it, he knows no one listened in. It does not let you go fast in the speed of light. A lot of people get confused and think the quantum weirdness will let you go faster than the speed of light. It does not. Quantum entanglement, you have to get the quantum entangled thing to the other person. Using a light, yeah. And once they get it, they can receive one message, and then they have to check back with you to see if that was the message you really sent. And then they say, holy cow, that happened faster than the speed of light. But by the time you ship the thing and they check back with you if they actually got the right message, it turns out it's always much, much slower than light. And yeah, quantum tunneling, I'm afraid to even say this, at very tiny scales, things actually do appear to hop faster than the speed of light, tiny distances. But only tiny distances. And the odds of them doing it successfully drop with the cube of the distance. And therefore your signal is picking up noise in the form of, messages not arriving because they're so much less likely to do it. And it turns out that you have to add so much to make it a reliable communications. You have to add so much error correction that your packets get so huge
Makes no difference.
that in fact it would have been much faster. It works out mathematically. It just doesn't work. You cannot use quantum either effect, right? There's quantum entanglement and there's quantum tunneling, and neither of them can be used to build a communications channel that goes fast at the speed of light. Even though they each sometimes do weird things that kind of seem like they're going fast at the speed of light, you can't use either for communications. And this isn't just me talking. There are mathematical proofs of this. It's done. Why is glass slower? Refraction. No, you got it backwards. Refraction happens in glass because light is slower in it. So when it hits the glass, it suddenly slows down. And there's an impact, and that makes it bend, and that makes it reflect. And all that is caused by the change of speed of light in glass. Copper is also slower. I actually have some questions about, like, is the light actually being absorbed and then recreated and then absorbed and recreated? Is that why it's slower? I don't know. I don't feel like I've ever gotten a straight answer from a physicist. Yeah, light's slower when it goes through stuff. Interestingly, you know what is, until recently, the slowest substance?
What's
You
that?
put light into this thing, and it slows down more than just about anything. Now there's diamonds.
Okay.
Light is so slow in diamonds. That's why they sparkle.
Okay.
That's why they sparkle. Because there's this huge speed shift when the light goes into the diamond and starts having trouble getting out of the diamond. Because
so it starts going every which way.
So it goes every which way, and you get the sparkling diamond
Wow.
effect. That is caused by light being so slow inside a diamond. All right. But anyway, back to Speedify. Besh is asking, what should I buy together? 10 phones on one laptop. I get 10 friends willing to give me their phones. What do I buy? I got to say, there's a lot to be said for USB-C. If you tether the phone, to a powered hub, a bunch of them, you can put together really high speeds. So that would be my advice, Besh. Why will my phone not shut up? All right. Is that my phone or is it someone else's phone? All right. I think it's not my phone. There's a phone ring somewhere in the studio, but its volume is very low. So my advice would be USB-C if you can make it work. Either, one cable per port. If you have more than you have ports for, you can get a powered hub. Because otherwise weird things can happen when a bunch of phones try to charge their batteries over USB-C from a laptop. That can provide power, but wasn't meant to be a charger for that many devices. I will say 10 phones, probably too many, right? By the time you have, one on Verizon, one on AT&T, one on T-Mobile, now you've got great internet. One or two of them are working great wherever you are. After that starts being diminishing returns. They can start interfering with each other if they're too close to each other. They can start, grabbing all the bandwidth off the tower. So it's diminishing returns after that. I definitely would try to have more than one phone, get on more than one carrier. That would be great. All right, Brian says the minimum latency one way between the US and South Africa would be about 43 milliseconds. So the minimum round trip time would be about 86 milliseconds. So that is your basic, speed of light kind of, probably, he may well be including going through one or two repeaters in the middle. But yeah, so that's your physical limit, right? You can't be that far apart and have 20 millisecond latency. What Wi-Fi device is reliable and secure to use in a domain environment and also to manage a central app? I'm not quite sure what you're getting at, Lynn. I'll say OpenWRT, pretty good. I'm not quite sure what you're saying, but you can have, SSH on it, yep. And people have set up, remote access to them, and it supports all sorts of encryption. It's very configurable. You can also, set up your OpenWRT to be completely open. Mm-hmm. In fact, a complaint is probably that it's too configurable.
Don't misconfigure. Don't vibe code it.
Yeah. Could you please elaborate regarding what Speedify module is closed source and which one is open? I can only find Speedify Pi, which seems like a wrapper, not an actual networking library. Yeah, Speedify is closed source. Mm-hmm. There are a bunch of libraries. We've done libraries we've contributed patches to. Linux kernel, I think we've contributed some patches to. But of course, Speedify is not open source. It is. We need to be able to go fast. We are reinventing the protocol all of the time. Yeah. Now there's a jitter buffer in it. There wasn't, and there are changes to the core protocol. It's not open source. A neat thing we do, by the way, is that we don't have backwards compatibility built into the Speedify code at all. So you guys can decide if this is awesome or not. I think it's awesome. Mm-hmm. On the server, we just have different if you are running the old version of the software, when you connect to the server, it fires up a copy of the old version of the server software for you to talk to. Yep. And if you're running the newest version, we run a copy of the newest server-side software for you to talk to. So there's no backwards compatibility, right? The server doesn't know how to talk to old versions of the client. The client doesn't know how to talk to old versions of the server. We just write the best code we can. And if we want to change the protocol, change the protocol. We make huge changes all the time as we discover better ways to do things. And there we are. Besh is saying it's actually between 200 and 300 milliseconds South Africa to US. Right. So I think, Besh, what you're saying is real world, you're getting 200, 300 milliseconds. Brian is saying that if things were perfect, if every router was lightning fast, every connection was fiber, nothing in the middle that's slower, and no packets were dropped at all, the lowest you could ever get is into the 80s, which is not denying that what you're actually seeing is in the 300s. It just implies that, there's some internet connections in the middle that aren't quite as fast they could be, or some are dropping packets, or the memory buffers are too large on some of the, like, there's lots that could go wrong. He's just saying no matter how much money you spent, you can never get it below the 80s. And so how much higher it is than the 80s is a measure of how imperfect things are. Does that make sense? without reading that, I assumed it was because light is bouncing around a lot on a tiny scale, which increases the distance enough to slow it down. I don't think that's it. The light. So have you ever seen how much engineering goes into a fiber optic cable?
I'm not.
It's not just a strand of glass.
Okay.
They add impurities to it. I don't remember, is it more on the outside or more at the very core? But the point is, the speed of light is faster in the center of the glass strand than it is on the outside. So if the light goes down the center, it gets the full 70% of the speed of light. But if it starts trying to escape the cable, it starts hitting slower glass, which makes the signal bend back towards the center.
To bring it back in.
And so there's all this engineering in that little strand of glass.
Wow.
They're adding impurities in order to make the laser always bend back to the center where it can go nice and fast and can't escape, right? That's why bending a fiber optic laser doesn't shoot out, because as it gets close to that corner, it starts slowing down and being forced to bend back towards the middle. So much thinking went into these things.
It's crazy.
So many
That's
smart
awesome.
people out there. All right. What would be best practices for transporting SRT over Speedify bonding? What are the best strategies considering Starlink plus 4G plus 5G plus fast dedicated links? I think for the most part, I think the defaults are pretty good.
Yep.
Right? We've got streaming mode on, which should make it recognize that your SRT is high priority. If you want to make sure it uses the 4G, 5G, right? One of the things, the auto priority right now decides that Starlink is primary, use it all the time, and the 4G, 5G is secondary, you try to use a little less. Starlink's frustrating, right? It's a weird one because we have these categories of use it all the time or use a little bit less, and I feel like Starlink adds a new category between the all use it almost all the time, because it's not quite as unlimited as it used to be, right? They're shrinking the data caps. So anyway, if you just want to make sure like that the SRT goes through, it could make a lot of sense to make the 4G and 5G primary. I would watch then, pop over and look at the, when you set up, it's worth doing some testing, right? If you see loss on one of the cellular connections, I guess, is that Mike's phone? Got the colors too similar right now. Let's I don't know. Do we have more choice of colors?
We'll get a color wheel in there.
Oh, God damn it. All right.
Probably yellow or something.
Yeah, all right. You're going to be peach.
It's fine.
There we go. So who is it? Mike, it's your phone, man.
AT&T.
All right. So I would look, and if you see one connection, you move all your 4Gs, 5Gs to primary. Take a look, though. If one of them is showing loss, if one of them is showing latency, bump that back down to secondary.
Yeah, you don't want
to. Just give Speedify the hint. All right, you use it a little less. If you can see that it's not good, give Speedify the hint. It ought to figure it out. All right, Andreas, where are you guys located physically? Philly. Oh, we got one guy in Northern Virginia. We got one guy in Seattle. We got a couple people in Serbia and Romania, but vast majority, pretty much all the software is written, I'd say in Philly, but in Eastern Pennsylvania. Some people moved out of the city so that they could have a pool during COVID. And all right, can it bond Wi-Fi and wired connection? Yes, but the caveat,
different.
You want them to have different internet connections. So right here, I'm bonding Wi-Fi and Ethernet, both going to the same Comcast cable modem, and I actually don't think it's doing me any good at all. Right? The two cellular phones I have hanging off, they're probably helping me. But yeah, if you're going to do Wi-Fi and Ethernet to the same internet connection, it's really not going to help you.
Yeah.
Brian Purnell seeing a solid 275 milliseconds between Philadelphia and our servers in Johannesburg. Right. Yeah. So he thinks it's probably actually going through Europe. Yes.
Andrew,
Okay.
we'll make this a priority.
Yeah, well,
I think it needs to be.
I gotta be honest, I'm confused. I thought that 4 months ago we like tripled the number of colors.
Well, we only
And
10 or 12.
I don't know what happened here.
We just need a color wheel.
I guess this is why is CrowdStrike still recommended to us after the debacle blue screen. I think we have a video about that too. Go check out our YouTube channel afterwards.
Yeah.
The answer is the credit card companies thought it would make you more safe, so their lawyers put it into all the contracts that companies must make you run something like CrowdStrike. And so even though now everyone's like, well, that was a terrible idea. Why did we agree to that? It's in all the contracts. Both sides have signed it. It's not even like the credit card companies can just take it away. They can't go and just edit your contract.
No.
So it's stuck, these well-meaning things. So just this summer, like 3 weeks ago kind of thing, in July, Microsoft, 1 year after the CrowdStrike thing, has finally rolled out for testing some of their fixes for what went wrong with the CrowdStrike. They finally have an API for security apps to be able to do what they do without being in the kernel. If your computer blue screens of deaths every time it boots, after a couple times, it'll start not loading the drivers that caused it to crash.
Oh,
revolutionary!
Whoa.
Revolutionary!
We needed this 20 years ago.
Yeah. And finally, to make sure that no one ever gets a blue screen of death, if your computer's kernel crashes, the screen you get is black.
Oh. They're trying to divert the news, huh?
I don't know what they were like. Did they think that would make us stop saying B-sods? It's black still starts with B. So I'm not sure what their point is. What is your actual metrics, packet loss, jitter to computer connectivity quality grade? That's an excellent question. And when we're back to debating, a lot of it has been historically throughput based here, trying to improve people's speeds. But a lot of the quality of experience experts in the world are saying we're too obsessed with throughput, and that, giving consistent latency is more important. And so, adding jitter buffer, we're looking at a number of things. There's Orb is new. Cloudflare has their AIM, where they have an open source project and papers where they explain what they think makes a good internet connection. So, I don't know. We're back to arguing whether we should adjust our definition of good internet. Maybe we should give you a choice. There's some good, Cloudflare in particular, their thing, they've got different measures. They've got one set of calculations for what's a good internet connection for a gamer, what's a good internet connection for browsing the web, and they're different equations on how they combine latency, loss, jitter, bandwidth. And so maybe that, you say, I'm gaming, and now we become obsessed with latency, and then you say, oh, no, it's more work for the user to make them pick. But maybe we can see what apps you're using. I don't know.
Yeah, I thought like loading a profile, what you wanted to do. We throw that around.
Yes. Miami to Johannesburg, back to this U.S. to South Africa, goes through Marseille, France. So you're not going in a straight line, the fiber optic cable stretched between the two. You're going to Europe, and then you're probably following the coastline of Africa down, right?
Yep.
So Vadim. The star ratings that we put next to the connections. Yes. Sorry. Good catch. That's the MOS score. MOS. It actually stands for Mean Opinion Score. It is a measure from voice over IP.
Mm-hmm.
It is using loss, latency y, and jitter to calculate how good this would be for a voice call. Interestingly, it's for voice calls. It doesn't use bandwidth at all.
Nope.
If it gets a small number of packets through nice and quickly, you'll get an excellent score. CrowdStrike does say that they've improved their quality and release processes.
What else are they going to say?
Yeah, but what else would they say? Yeah, Vadim was asking. Yeah, so the stars rating, it's MOS, Mean Opinion Score. It's a voice over IP thing. There are a bunch of articles about how it's calculated.
Mm-hmm.
It's loss, latency, jitter, and it's trying to calculate how good would it be if you made a voice call over your internet connection. I think it's pretty accurate.
Yeah.
And it's called Mean Opinion Score because apparently they had thousands of, or hundreds of people do thousands of calls where they dialed in different amounts of loss, latency, jitter, and then asked how, what's your opinion of how good this call was, sound quality wise. And so they came up with equations that combined loss, latency, and jitter, and pretty much matched what most people said was the quality. So it's Mean Opinion Score. All right. What antivirus do you recommend? I just use Windows Defender. It seems as good as any of the ones that are sold, and it is not adding more crap in Windows. I've had very bad experience with like McAfee. That's it. I don't claim to be an antivirus expert. I use nothing on my Mac.
Yeah, I was going to say just use a Mac.
Just use Mac, yeah.
Yeah.
But yeah, on Windows Defender seems pretty good. And that's about it. All right, 10:52. We've been going.
Yeah.
Is there anything we
nice
haven't
question,
talked
crowd, today.
Yeah, so go look at our YouTube, particularly our shorts.
Yeah, great stuff.
There's
lately.
a lot of little videos, us talking about Starlinks and phased arrays antenna and TAR lasers. Fun stuff. And yeah, I think that's it. All right. Thank you, Mike.
Of course. Thank you
to everyone who asked questions. I feel like we're getting to a pause here, so I'm going to let you guys go. All right. See you all online.